Hey everyone, my name is Vikram Dumal and I welcome you all to a deep dive into CDN Content Delivery Network Architecture. Today we are going to break down this complete CDN diagram, explaining every single term and its purpose. To make it tangible, let's use the analogy of our fictitious movie streaming service, Streamverse. Our main movie library is stored on our origin server in London. Our viewer is in New York. When our viewer in New York clicks play, their device's first job is to find the closest server. It does so via a DNS lookup. Okay, so now let us talk about the request and routing. The DNS or domain name system is often called the Internet's phone book. Its job is to translate a human readable domain name like streamverse.com into a numerical IP address that computers can understand. So the request is going from this end client to DNS, and DNS in return is giving back the IP address to the end client. Our CDN uses a special routing method called Anycast. Anycast is a networking technique where multiple servers, even in different parts of the world, can share the very same IP address. When a user tries to connect, the Internet's core routing protocol BGP or Border Gateway Protocol automatically sends the request to the topologically nearest server. Think of BGP as the global postal service. It knows the most efficient route to deliver the request to the closest server with that specific IP address. This is far more efficient than a single distant server having to handle every request coming from New York going into London. Instead of that, using Anycast and BGP protocol, we are able to get the IP address of the topologically nearest server. Sometimes a client might be directed by the HTTP redirect. This is a response from server telling the client, right? So from DNS to the client saying, hey, I don't have this, but you can find it over here. And it provides with a new URL to go to. It's a way to redirect traffic to the proper CDN server for that specific content. Let us now talk about the edge and caching. Once the DNS has done its job, the request is sent to the CDN's edge proxy server, which is located in this case in East US 1, which is closer to our viewer who is in New York. Before the request reaches our server, it passes through security servers. These are specialized systems that analyze incoming traffic to protect our infrastructure. A prime example is DDoS mitigation, where these servers filter out massive malicious traffic called denial of service attack to ensure legitimate users can still connect. Next, the request hits load balancer. This component's sole purpose is to distribute incoming traffic evenly across a group of servers. It prevents any single server from getting overwhelmed, ensuring high availability and consistent performance. The edge server or the edge proxy server itself is part of something called as point of presence or POP. A POP is a physical data center location where the CDN has its servers. They are strategically placed in high traffic areas, often co-located at ISPs. Okay, so this point of presence or POP are co-located at ISPs or IXPs. ISP or internet service providers are the companies that gives us the internet access. Or the IXPs, which are the internet exchange points. These are the physical locations where different internet providers and content delivery networks agree to exchange traffic directly with each other instead of paying a third party. This is key because it minimizes the number of network hops and the physical distance data has to travel. So to recap, we have this edge proxy server, and this edge proxy server is basically a part of point of presence which is co-located either at ISPs or at IXPs. Now inside each proxy server, we have a tiered caching system. The fastest, okay, the fastest data or the hot data is present or cached in RAM, which is our random access memory. While the next tier is SSD or solid state drives. It is slower than RAM, but it is still much faster than our traditional hard drives or going directly into our origin server. It stores what we call the cold data, like the movies that are less frequently watched but still needs to be served quickly are part of this cold data storage, while the most popular movies can be part of this hot data storage. Let us now talk about multi-tiered workflow. When a viewer requests a movie, a viewer who is sitting in New York is requesting for a movie, the Edge proxy server first check its own cache, whether the movie is available or not. If it's available, we call it a cache hit. If not, we call it a cache miss. In that case, the Edge proxy server checks with a regional cache proxy. Okay. Now this regional cache proxy is present in East US. If it finds that movie, it will give it back to the Edge proxy server. But if not, then ultimately it needs to go to the source of truth, which is in London. So this is our multi-tiered workflow from client to Edge proxy server. If it doesn't find, it goes to the regional cache proxy server. If it doesn't find, ultimately it reaches to the origin server. Let us now talk about the control plane and consistency. The entire system is governed by the management control layer. This is the CDN's brain, where we define all the rules. It is separate from the data plane where the actual content flows. This layer controls our content ingestion strategy. With pull caching, the edge server only pulls a movie from the origin when a viewer requests for it, right? While with the push caching, we proactively push the new movies to the edge and regional caches before anyone asks for it. So there are two techniques, pull caching versus push caching. The control layer also defines caching behavior through multiple HTTP headers. An HTTP header is a piece of data sent with every web request and response. An origin server can use the cache control max edge header to tell the CDN and the client's browser how long to store the content. For revalidation, the server can set E tag or entity tag, which is a unique identifier for a version of a resource. A client browser can then send back an if none match request to ask the CDN if its cached version is still the latest one without downloading the entire file again. To ensure viewers don't see outdated content, we have several strategies. So these are the cache invalidation strategies like TTL, polling, TTR, or leasing. What is TTL? It is time to live, the simplest method of all, where cached content expires after a set amount of time. Polling. The edge server periodically polls. Now in this case, the edge server will periodically poll the origin to check if the content has been updated, of course through the regional cache proxy. TTR, which is time to refresh. Similar to polling, the edge server can serve the stale content while revalidation is still in flight. Back to the end client. Now leasing, what is leasing? Leasing is a more advanced distributed system approach where the origin server, okay, this origin is granting a set period, a lease period for this content. The CDN must renew the lease before it expires. Let us now talk about performance and analytics. Now finally, our system is optimized with advanced technologies. The connection between the client and our edge server uses modern protocols like HTTP2 or HTTP3 Quick. HTTP2 introduces multiplexing, allowing multiple requests to be sent over a single TCP connection, reducing overhead. HTTP3 goes even further, using a new transport protocol called Quick that provides faster connection setup and better performance, especially on mobile or lossy networks. For video, we use adaptive bitrate streaming or ABR. This technique breaks a movie into many small numbered chunks at different quality levels. The viewer, in this case again, the end client, the viewer's video player constantly checks their internet speed and requests the next chunk to the proxy edge server. Okay, now while it is requesting the next chunk, it will request in the appropriate quality to ensure a smooth buffer-free viewing experience. Throughout this entire process, every step is logged and sent to our reporting and analytics layer. This data helps us monitor performance, understand the user behavior, and it provides the feedback to the DNS and also back to our origin server, which is in terms of our management control layer. This will help us with the continuous optimization or a feedback loop. So, how do the real streaming giants like Netflix, YouTube, or Prime Video work? They all have few things in common, like their massive global scale. They all operate on a global scale, just like Streamverse, using a multi-tiered CDN. They all have a hybrid approach, meaning they all use a combination of their own CDN and a public CDN to maximize the reach. They also push the popular content to edge locations based on predicted demand, calling it the content pre-positioning. And lastly, as we just saw, all of them use adaptive bitrate streaming to deliver the best possible video quality to the end clients. So now this diagram accurately illustrates the CDN architecture that we have discussed. With our origin server in London and our viewer is in New York being served by a nearby edge proxy server in East US, going through a multi-tiered approach through regional cache proxy in East US. Understanding these components and their interactions is crucial for delivering a high quality online experience at scale. Well, now, if you found this deep dive into CDN architecture helpful, please hit the like button and subscribe for more content like this. Thanks for watching.